first up is Mr. Steve Woodruff. Steve is a soil health specialist with NRCS, stationed at the Eastern Regional Technical Center in Greensboro, North Carolina. Steve has been a key instructor in our national NRCS Pasture Ecology School, and his experience teaching the principles of soil health all across the country helps him communicate how these principles apply across all kinds of soils and ecosystems. So we're excited to have Steve with us this evening. So Steve.
Thank you, Johnny, and thanks to NC State University and the whole Amazing Grazing team for allowing me to participate. I am actually talk about me being all over the country talking about soil health. I have had the privilege to do that, and I'm actually in exciting, beautiful Holiday Inn Express in Albemarle, North Carolina tonight. We're doing a soil health course for our folks down here as well, and we spent the day out in some pastures and some cropland fields, and that was really exciting. And I do mean that because I do get exciting after my soon to be 40 years working for this agency. I really got involved with soil health when I learned about it, say in about 2006. And so I've been passionate about it ever since then, and have tried to immerse myself into it as much as I possibly can. Soil health on grazing lands has not gotten the as much of the discussion as it has on cropland, but there are more and more folks in your perennial pastures, perennial grazing lands that are taking more of interest in soil health. And you know, soil health on your pastures, on your perennial pastures, a lot of the soil health kind of mimics what you do in rotational grazing, good rotational grazing. There's a lot of comparisons that you can make there. But I think a lot of it that the folks that are interested in soil health put an importance on soil health just as much as they do the grass that's growing above the ground and how the livestock looks as well. So they have just as much thought process in what's going on below the ground as what is going on above the ground. That's probably the biggest difference. What I'm going to do over the next few minutes, and since my thing doesn't have a clock on, I have to keep an idea of my time. I want to give a broad brush a little bit on soil health for a few of you that may not as in tune with it, and then maybe more specifics on its relationship to grazing lands. So the first thing is that always comes up is does grazing impact soil health? And one of my cohorts from years ago, Ray Archuleta and some others, have always said, put some animals on it. All your prayers will be answered with soil health if you just put some animals on it. And that can be true. That can be a big help, but it can also have, as you probably know, some negative impacts as well. We'll talk a little bit about manure and managed grazing, how much of a positive benefits they can have towards soil health. But you know, your use of urine and waste distribution and poor grazing can have negative effects, as you would probably imagine as well. So grazing is a tool for soil health, and what you give into it, you can get back in it, but it can have negative effects as well. So just a little bit about soil health for those of you that are not as familiar. It's that continued capacity of a soil to function as a vital living ecosystem. So continued, when we hear that term, we think about sustainability. And when we think about function, we expect it to do things for us. And some things like living ecosystem is something that just a few years ago, I really never thought about as our soils being alive. And I never thought it being a function. I always thought maybe it was just more that we put our plants into the ground and we used our amendments to grow those plants, whatever we add into it. But we can have big impacts on some of these different things depending on the level of your soil health. And I really want to concentrate primarily on these first two as we get into this, because I think those are two vital important things to producers when we talk about soil health and say, why do I care about soil health? These are big items and issues which can be impacts when talking about soil health. And those are water, whether it's infiltration or availability, and nutrient cycling. And we've talked about that in the course I've been in today and yesterday and again tomorrow, how important and how much we can impact what the producer is doing, not only what's going on with the environment, but what the producer can do as far as impacts on his bottom line and yield, or what he's doing with his livestock operation. I want to talk a minute about the soil food web, and don't get too scared when you see all these arrows going. But I think this is, like it says, it's a very simplified soil food web, but I think we need to talk about it just for a minute or two to get an understanding of what's going on and what comes from what, because you can't really know some of the slides going forward unless you know what's happening here. Of course, we use the sun's energy to convert into chemical energy in the plant. Of course, we call that photosynthesis. And when we do that, the plants are able to take in that carbon dioxide, right? That CO2, releasing the oxygen back. In a simple terms, it takes that carbon to build those plants, to build up those plants. And the carbon, it goes from the leaves down into the roots to expand those roots, but to also give off these exudates into the soil. These attract things that are attracting the biology. And why would it do that? Because it is willing to give up some of its carbon, some of the things that it has, some of the simple sugars that it has to the biology. In return, the biology will give nutrients back to the plant in forms that the plant can use. So it's just a great little relationship that they have. And that's really the basis for a lot of this nutrient cycling. That's your most simplistic version of what's going on there. And the other thing, the other byproduct of that, between what comes out that's pooped out the back end of the biology or through dead bacteria, protozoa, and nematodes, you start getting this stable organic matter. And that plays a role in what we're going to talk about as well, having that stable organic matter. So you not only start getting this nutrient cycling, but you start getting the stable organic matter, which becomes the home and places where you can store a lot of these nutrients. But each one of these arrows represents energy flows. And the more diverse biology you have in your system, lots of different kinds of things, the more chance you have to keep that energy in your system, and the more chance you have to have more of the cycling of nutrients and more activity within the soil system. So that's just a big important process to keep a lot of those things in the soil system. And what's going on here, when you see the bacteria and the fungi, those are really small, but they number in the millions and millions and billions of individual species. And as you get further along to the right, to things that you can see, they become smaller, but they all play a key component in that full soil food web. So you will not, when you go out walking in your pastures, you will be not able to see the bacteria and the mycorrhizal fungi, for instance, and the protozoa, but you'll be able to see some of these bigger things, some of the bees, the pollinators, the spiders, the mites, all these things. And when you have those healthy systems above ground that you can see, you probably have a healthy system below ground as well. So when I talked about the building of organic matter, and when we get into that, we're talking about its ability to hold more nutrients, to have greater aggregation, and be able to infiltrate more water. You all know as well as I do that we get lots of hard rains, and then we get periods where there's no rain. And our soils need to have the ability to take in the amount of water it needs, to release the amount it doesn't need, and hold water for a time period during some times when it becomes dry. And you can do some of that as you build up some of the organic matter in the soil. That plays a key role when you compare that to aggregation. And you can see here as an example what is going on. Let's see if I can minimize this. Yeah, so what is going on between cropland, continuously grazed pasture land, and rotationally grazed pasture land as well. These are infiltration rates. So well-managed rotational pasture can have a quick infiltration, a lapse of 5 minutes. How many inches an inch can get in that soil within 5 minutes. Continuously grazed, very slow in the cropland, of course, continuous cropland, much slower than that. The point being, when you start rotating your pastures, have a good rotation where you have building organic matter. You can see on the right, the difference in your organic matter layers, the difference in those soils there. It could play a big role in that water cycling and using that water. That cropland on that right, especially, but even that continuous pasture land represents water that's being run off and not used by the plant and losses. So that's a key point. A little bit, this, I swear that I promise this is going to be, I think, the only schematic here showing what's going on with some nutrient cycling. But when you talk about, I think it is kind of important when you talk about nitrogen, when it comes out the back end of the livestock, it's in the organic nitrogen phase, but quickly is converted to ammonium. And ammonium, of course, is a form that plants can take up, and it's a form that's very stable. But through other bacteria and other processes in the soil, it can be converted to nitrate. And nitrate, the good thing about that is also available, plant available in the soil. And why do I even talk about this? Why do I think that's important? Because if you have if you see that bottom part there, if you have lots of biology in the soil and lots of plant roots growing in the soil, when that organic nitrogen gets converted to ammonium and that to nitrate, there are plants and microbes that will take up that nitrogen and not allow it to be lost. As you see off to the right, you see losses of volatilization, you have losses to nitrate in runoff, and you have losses through leaching. But the more living plants you have and the more healthy biological systems you have in the soil, the more potential you have for that to be tied up and reused. And that is what we call nutrient cycling. And that is, in this case, it's nitrogen. And that's just key, because we don't want to have to go out there and spread a bunch of nitrogen to get the benefits, from that. We want to take what's given with the recycling through the animal. And that's what we have going on when you have healthy plant roots and a healthy biological system. They're competing. They have the opportunity to take that and use it, and that's cycling. Soils are always going to be leaky to some extent. You're always going to have some losses. You're always going to have some ammonia losses, especially from urine. You can't help that. And there's going to be some losses through leaching, that nitrate. You can't help it, but you can minimize that by having a healthy system. So let's make the best use out of our nitrogen that's available and recycle it in our systems we have out there. Soil is a living factory. And so when I get into the principles, think about this. What we want to do to have healthy soils, we've got to give those organisms the same things that we want. And we want food. The main things we want: food, water, shelter, that habitat. Those are the same things that people want, and we need to provide those to the biology. If we provide those to the biology, they will work for us to build those aggregations for that water infiltration. It will build it for holding nutrients, recycling nutrients. It will work for us, but we have to do it something for them, and we have the management capabilities. We have the management capabilities to do that. So what are those? And so before I get into the principles of what we want that to look like, here's some anti-principles, especially, I guess, if you look in the top right photo. I think Jim Green, who I worked with, took that years ago, and I've seen this recycled all over the US. But non-functioning soils, obviously, it's not a good rotational soil. There's not pastures, excuse me. That you can tell it's not, but it's not meeting any of the principles that we're going to talk about, and it's not going to, the biology is not going to give you anything in return. And especially the bottom left, that's after during a rainstorm, that pasture, it's the same situation. You've got compaction, you've got no aggregation in the soil, and your water is running off. So these hard rains, you're not able to use the soil, the water that's coming in there. So what we want to do, and thinking about what we need to do, we need to provide that habitat for the soil biology, for them to be healthy, to work for us. And those things are minimizing the negative disturbance. And this is a little different than I say with cropland. It would normally be just minimize disturbance, but we're going to talk a minute about negative disturbance. We're going to talk about maximizing cover, a diversity, and enhancing the continuous living roots. I call this, because in perennial systems, we have living roots compared to cropping systems where, you know, certain years are fallow, where there's no root systems at all. We want to grow and enhance those living roots. And we do that through photosynthetic activity, rhizosphere, and that's the activity right along the roots to increase that organic matter. This is just a crested wheatgrass because I've used this presentation in other parts of the United States, but I think it's a great photo. It shows that when you can do this, you know, when you pull up roots out of the ground, and a lot of times there's the soil that's attached to the root hairs. You see balls of soil attached to the roots. That is the glues produced by the bacteria along that rhizosphere, along that area, along the root, so they can so the biology can get in there and have that symbiotic relationship. Give the biology, say, give me carbon, give me these exudates, and I'm going to give you back nutrients that you can use. But you can see this for yourself when you pull this out of the ground. You can see some of the soil that's attached, and these root balls attached to the soil. That's when you've got some active things going on along that rhizosphere, and that's pretty interesting. And I wouldn't have thought about that before that. But most of the biological activity in the soil, most of it happens right along near that soil, near that root. So if you can keep that good, healthy root systems in your soil, then you're going to more likely have a good system where you're cycling nutrients and building organic matter. Keep in mind that as you take off your leaves, your above ground leaves, which is where you get your photosynthesis from, you're reducing the ability for the plant to extend roots and grow roots. Roots, you know, the plant sometimes when it doesn't have a lot of leaf material, it's just barely hanging on, trying to stay alive. So in fact, when you, in this particular example, this is not true with every perennial plant, but it's pretty, you know, it's a pretty good thing to go by. When 50% of the leaves are removed, you're really getting to a point that your root growth is stopping. So that's a good thing to think about when we're thinking about these stop and start heights of plants, why we need to do that. You need to keep building those root systems and keep extending those deeper into the soil profile. So that's important to do. Here's some old material showing, you know, fescue when you rotate it versus non-rotation, the impacts it can have on those root systems. It's a big deal. And so having an active rhizosphere where it can not only work with the biology, but go deeper to grab water sources is a big deal as well. You can go deeper in the soil, and if you can allow these roots to go deeper, they can mine for nutrients that are deeper in the system. And you can see here's this is something out in Missouri, that as you go deeper in the profile, there has been things like calcium and the pH is higher, magnesium at lower depths. So never discount what has leached down through the system. And if you have healthy root systems, its ability to go down there and grab it. So the bottom line on those living roots is, this is a very basic schematic here, but if you're on the right, if you have continuous grazing periods with no recovery, you're going to have smaller plants and smaller root systems. Shorter grazing periods, which are, higher with long recovery periods, which you might have in high density grazing where you're moving them fairly often, you're going to really have the opportunity to grow those roots deeper. A lot of our rotational systems are somewhere in between, which is not too bad. So talk a little bit about diversity here. Got a lot of, I'll just go right to this. And why do we want diversity in the system? When I showed you that schematic with the soil food web, and I said we want lots of different things in the system. Well, the important thing of lots of different things is if you have lots of different things above, it feeds lots of different things in the biology below the ground. If we have a healthy, diverse population below the ground, not only is it doing those things that we talked about, but there's always the bad things down below ground that, we don't talk about, but they still exist. So if you have a healthy population below the ground, it can outcompete and work to against the things that are bad, say bad nematodes or some bad bacteria, some bad fungi. You're not going to get rid of it, but remember, the healthier that system is, the more diverse and larger those populations, it will be out to compete, and you're more apt not to have as many potential problems through diseases and other things and such. And this example here, this is actually a picture on the left from a very diverse pasture in Virginia. And I grabbed this from somebody out in the Midwest of what you might see on a diverse range as well. Just real quick, this is an old slide showing some weed species and some things that we wouldn't think about grazing, some of them, but you can see that there are some, pretty good amounts of protein in some of these species as well. So, and it's something that Matt Poore touched on a little bit, that there's some, maybe not everything out there is so bad to be grazing, and they can provide good things as far as the diversity for the soil population below the ground. This is also, I had somebody take this of me, that's me years ago, and this is at Matt Poore's. The idea was that some people are doing annuals on perennials ground to renovate their pastures, and they go in to put in a bunch of annuals for maybe a period of time. It could be just one season, or it could be a couple of seasons. The reason I included it in here is it's providing diversity. It's really boosting that diversity for that period of time, and really pumping up not only the potential for organic matter, but that diversity below ground in the soil. I want to talk really a bit also about residues, because residues can moderate the soil at the soil surface. It's not as big a deal with some of our perennial systems because they're so thick, but if you think about it, in between a lot of our plants, there are residues, and that is important because that feeds the soil biology at the surface, but also can help moderate temperatures as well. This is an older slide from Nebraska, but it just illustrates that that middle one with the grass with the litter removed, as opposed to the top one, grass with litter present, that having the litter in between the soils made a big difference in the infiltration rate. Now, I don't have the full context on what was going on with that soil, but the bottom line is having litter between your grass is a good thing. Mark Bromley out in the Midwest, he does higher stocking density, so he tramples a lot of his residue down over the left. By doing that on the right, during a drought, he had a lot more grass available throughout that particular season. And I can't remember what year that was, 2011 or 2013. Why? How's that possible? Mainly because he's moderating the temperatures with that residue at the soil surface, and he's keeping moisture there for a longer period of time. And so that's what he was able to do. I know I'm going through this pretty fast because I'm running out of time. This is my last one, talking a little bit about, I said, minimize negative disturbance. Now, when I talk about disturbance here, when we talk about disturbance in cropland, we're talking about tillage and we're talking about pesticides, we're talking about too much fertilizer. But here, a disturbance can be good if the hoof, the plant, and the manure and soil all work together. If they're not talking on the same, they're not playing on the same sheet of music, it could be disastrous. But if they work together, meaning you don't have the hoof there for too long, and you keep the plants, plenty of residual on the plants, you allow the manure to be applied to the soil there, but then moved to another area, it can be a real positive thing. Manure can have so many positive effects. We can't go into all these physical, chemical, and biology, but they all have surrounded and have impacts related to organic matter, but just too numerous to mention. But if they're done in the right way, manure can be your friend. Why? Because they're accelerating the soil health. You think about it, you got the rumen microbes converting that forage, and when it comes out the back end, it's already already moved to the first level of becoming some stable organic matter. So it's going through the first process. Real quick, just real quick on how did we get some of our best soils in the Midwest? By the buffalo over years and years and years. And I'm not saying that we need to get really intensive grazing, but it is a tool in the toolbox to improving soil health. If you have a continuous system where the stock density is 1,000 pounds per acre, you can see that manure is concentrated in some areas and not in others, and grazing is inefficient with a low stocking density on this 15-acre field. But what happens when you have them grazing for one day? Again, I'm not saying that, well, we've got to go to 1 day grazing and move them every 1 day, but I'm just saying the more intense the grazing is, the more potential it is for better distribution of manures and better for the livestock. You're not overgrazing. You're more undesirable plants like Matt Poore talked about are grazed, and more animal performance. If you really get crazy, you can do it. Even more so that you went from, let me back up, you went from a 15,000 pound stock density to a 60,000 pound stock density. The same amount of animals, you're just tightening them in more, and you're moving them more frequently. So this is something that shows that that it takes some research that was done, and it takes on a continuous situation where it takes 27 years to get 1 pile of manure per square yard on a continuous rotated pasture. But if you go down to a 2-day rotation, you can get that manure 1 pile per square yard. It only takes 2 years to do that. I hope that makes sense. And there was not data on the 1 day or the twice a day. The bottom line is, if you want to really get that manure deposited over the whole area, you have to move them faster, move them more often, and tighten them up there as well. I'm going to stop there. There's just more information here on more examples on that. And the bottom line is, think about those things that will help the biology by giving them that habitat, the food, the water, the shelter. What do we do to do that? And that is those things such as that diversity, that keeping good, healthy living roots throughout there, minimizing negative disturbance and maximizing that cover. And when you do that, the biology will work for us to provide better infiltration, better use of our water, and better nutrient cycling, so we don't have to rely on external sources. So I'm going to stop there. I know I went just a little bit long, Johnny, so I appreciate it.
Thank you, Steve. Yeah, great job. And, if you start bunching those cows up like that again, the neighbors are going to start talking about us again, at the coffee shop for sure. So
Yeah.
No question about it. No question. But I do think that, what I got from Steve's information there is that if you needed one more good reason to improve your grazing management, Steve just gave you one. improving soil health and building soil health. So Steve, we really do appreciate that.
Sure thing.